9.6, solving rational equations. What we're going to do in this lesson is we're going to solve rational equations, and we're going to use rational equations in solving problems. Don't forget about extraneous solutions. All right, extraneous solutions can be introduced when you multiply both sides of an equation by the same algebraic expression. An extraneous solution is the solution of the derived equation, but not the original. Remember, you must check all solutions of derived equations in the original equation to find out whether they work or not. All right, so solving rational equations. Solve 5 times 2x minus 2 equals 15 times x squared minus 1. All right, so let's look. Step 1, I'm going to cross multiply. So I'm going to get 5 times x squared minus 1 equals 15 times 2x minus 2. Notice I didn't simplify this right off the bat. Okay, and we could have. But let's just go this way. 5x squared minus 5 equals 30x minus 30. Okay, let's get everything to one side of the equation, set equal to 0. Isn't that how we solve quadratics? So I have 5x squared minus 30x minus 5 plus 30 equals 0. See what I did to both sides is I subtracted 30x and I added 30. Okay, now sum like terms. So I got 5x squared minus 30x plus 25 equals 0. I can factor out a 5 now, right? GCF of 5. So I can write this as x squared minus 6x plus 5 equals 0. Okay, well, let's x factor this. A times c is 5. My b value is negative 6. So two numbers, both negative, give me product of negative or positive 5 and a sum of negative 6. That'd be negative 1 and negative 5. So x minus 5, x minus 1. So x would equal 5 and 1. Well, let's go look at the original equation. All right. We could factor the bottoms out, and what you're going to find out is it's really 2 times x minus 1, and over here is x minus 1, so x plus 1. So what can my restrictions be? What can the denominator not equal 0? So x cannot equal 1, x cannot equal 1, and x cannot equal negative 1. So x cannot equal 1. So the only solution for this one is x equals 5. Okay. Next example. Oh, it's already done for you. All right, solve. So we're going to cross multiply. So we get negative 4 times x plus 2 equals 15 times x plus 2. Well, what do you notice we could have done with the x plus 2's right there? You could have just canceled them. Okay, but let's say we didn't see that. We go ahead and distribute and all that good stuff. So we solve and we get x equals negative 2. What do you know the restriction is? X cannot equal negative 2. So 1a is no solution. Going on to 1b. Let's look at what our restrictions can be first. So x squared minus 2. So that means x squared cannot equal 2. So x cannot equal plus or minus the square root of 2. And on this side, x cannot equal 4. So there are my restrictions. So let's look at this. And let's just cross multiply. So I have negative 2 times x minus 2, x minus 4, equals 2 times x squared minus 2. Multiply out the negative 2, so I get negative 2x plus 8 equals 2x squared minus 4. Let's set this thing equal to 0. So what are we going to do? We're going to add 2x and subtract 8. So we're going to subtract 8 and add 2x. So I get 0 equals 2x squared plus 2x minus 12. Let's factor out a 2. So when we factor out the 2, we get 0 equals x squared plus x minus 6. Okay, now we can x factor. A times c is negative 6. My b value is 1, so I need two numbers that have a product of negative 6 and a sum of 1. So 3 and negative 2 give me a product of negative 6 and a sum of 1. So I would have x plus 3 times x minus 2 equals 0. To make that work, x is going to equal negative 3 or x is going to equal 2. Okay, both of those answers work. So on to the next example, because it doesn't go against any of the restrictions. Okay, next example. Example 2, solving radical equations. So it says solve 1 over 2x minus 2 over 5x equals 1/2. Okay, so let's rewrite that. 1 over 2x minus 2 over 5x equals 1/2. Well, can we find the least common denominator to get rid of all the fractions? Well, I have an x, I have a 2, and I have a 5. So I have an x, I have a 2, and I have a 5. So 2 times 5 times x, what will that be? That gives us 10x. So if I multiply every term, both sides of the equation by 10x, remember I can, by the properties of equality, I can do whatever I want to the equation as long as I do it to both sides. So 10x, so let's go ahead and just rewrite it, 10x over 2x minus 2 times 10x over 5x equals 10x over 2. So let's cancel. 2x, 10x is 5. 5x goes into 10x 2, and 2 goes into 5x, 5x. So 2 times 2, you see that is 4, so it's going to be 5 minus 4 equals 5x. So 1 equals 5x. So divide each side by 5, isolate your x. X equals 1/5. Okay. Next example. All right, next example. Solve 4 over x minus 3 over x plus 1 equals 1. All right, there's a couple things we could do here. Okay, we can multiply everything by the GCF, or we can make 1 x over x. Okay, right now let's say you don't see that. Well, we know from what we just said the GCF was x times x plus 1. So multiply every term by x times x plus 1. Where did I get that? Well, there's an x and there's an x plus 1. So if I multiply every term by this, all right, we're going to be able to simplify a little bit. So it's going to be 4 over x times x plus 1 minus 3 over x plus 1 times x plus 1 equals x times x plus 1. Now, simplify. Those x's cancel and those cancel. So now I have 4 times x plus 1 minus 3 times x equals x times x plus 1. Okay, let's distribute. So it's going to be 4x plus 4 minus 3x equals x squared plus x. Okay, so let's simplify. So this side is going to be 4 plus x equals x squared plus x. So now let's subtract 4 since it looks like we have a quadratic, and subtract x. So I'm going to get x squared minus 4 equals 0. Well, that's a perfect square. So we know x is going to equal plus or minus 2. And what are my restrictions? Again, we probably should have looked at this first. Well, x cannot equal 0, and x cannot equal -1. So it's fine. So my answer is C. Oh, I lied. B. 2, -2. All right, aerodynamics. The aerodynamic covering on a bicycle increases the cyclist's average speed by 10 miles an hour. The time for a 75-mile trip is reduced by 2 hours. What is the average speed for the trip using the aerodynamic covering? Well, what we need to understand is the speed with the covering is the speed without plus 10, okay? So we're going to set up a distance, rate, time chart, just like the one below. So without the covering, our distance is 75 miles, our rate is 75 over t, our time is t. With the covering, our distance is still 75 miles an hour, but we know our time's reduced by t, so our time is t minus 2. So our rate is just distance divided by time, so 75 over t minus 2. So we have a rate with the covering. Let's zoom in. So the rate with the covering is 75 over t minus 2, which is equal to the rate without the covering plus 10, because we know the rate with the covering goes by an average speed of 10 miles an hour faster. So now we look, 75 over t minus 2 equals 75 over t plus 10. So we're going to multiply by the LCD, the least common denominator, which is t times t minus 2. We're going to simplify and distribute and then solve for t. Well, t is equal to 5 or -3. Well, since time must be positive, t must be equal to 5. And you plug everything back in and you solve for the average speed with the covering is 25 miles an hour. Okay, we'll work a couple of these on our own, or together I should say. Next example. Alright, Rose can jog 5 miles downhill the same time it takes her to jog 3 miles uphill. So we got an uphill and a downhill. We have a distance, a rate, and a time. Well, uphill, she can jog 3 miles the same time she can go downhill 5. She can jog downhill 4 miles an hour faster than she does uphill. So the rate downhill is equal to the rate uphill plus 4. Okay, so how do I find rate? Well, rate is nothing more than distance over time. So uphill, her rate is 3 over t. Downhill, her rate is 5 over t. Distance equals rate times time. Okay, so the rate downhill is 5 over t, so 5 over t equals rate uphill is 3 over t plus 4. Well, what's the LCD? Well, the least common denominator would be t. So let's multiply every term by t. So that's going to be 5t over t equals 3t over t plus 4t. So that's going to be 5 equals 3 plus 4t. Subtract 3 to each side. 2 equals 4t. Divide each side by 4. T equals 1/2. So our time is a half an hour. But what was the question? Find her rate each way. Okay, so her rate uphill was 3 over t, which is 3 over 0.5, which would be 6. Her rate downhill would be 5 over t, or 5 over 0.5, or 10. So her rate uphill was 6, and her rate downhill was 10. So the answer is C.